Okay, I already made a video on what not to do and the common errors for the lab report. Let's look at some of the other aspects of the lab report and kind of look at it from the beginning. Again, for a grade in our class, all you are turning in for the laboratory report to be graded are the introduction, the results, and the discussion. So that's what we're looking at there. So let's kind of look at what a proper lab report would include. So first of all, you don't need a cover page. All you need is something like this at the top. So if you look at the information that's presented, notice it's got a title, and it basically gives you the experimental results. That's so when the reader is looking at 10,000 potential studies to look at, the title will tell you what it is. So it succinctly describes the content that butter produces better quality cookies than Crisco. So this is a fake lab report that I made and modified over the years, but it kind of gives you the idea of how to do it. So notice not only does it have a title, it just has the person's name, the lab day, and then what semester it is. And that's more than fine. You just put that as a title on the top. It can be centered, it can be left justified. That doesn't matter. Your best bet is just to copy the format of this for the most part, and you should be okay. So note the heading, right? All caps, left justified, bold. Remember we said that one of the things that you were supposed to do was follow directions, and that's what the directions say. So do that. When you look at the format in general, right? It's left justified. You don't have to make it the same all the way across, right? That kind of screws up the spacing. The paragraphs are clearly shown by the indent, right? It's double spaced, it's a normal font, normal size, things like that. Note that the section is well documented with references. So even though you don't need a reference list, anytime we have scientific information or background information, right, we have the references. So there's not all of them, but underline many of the references that we have. So the opening kind of provides this general statement, and what you kind of want to do is you want to start out general and then sort of funnel down your information as you go through your introduction. So it starts out at a general thing talking about cookies and things like that in general, and then goes to a historical reference, right? So now we look at the historical reference here. So nearly all cultures baked cookies in some way, and look at that. What is recorded as the earliest cookie, and then sort of how cookies have evolved and things like that. Again, you don't have to have a historical reference in your lab report, but having some sort of perspective, whether it's historical or practical. The practical perspective of cookies is not extremely as important as it would be for obviously many of the physiology things we actually studied in class, but having historical references is a good thing. Notice even in the historical references, they're well referenced. Again, as the references in citation, so look at this one, shows two things. One, the author's name, Baker, right? And then the date of publication. And that's probably the easiest thing to do, put in parentheses after. We try to stay away from direct quotes. You should put everything in your own words if you can, and you should be able to. And notice that we have a variety of references. So we've got 1, 2, 3, 4, 5, at least 5 different references in this little section we can see of the introduction. So again, you start out broad and then you become more narrowed. What this one did, it gave a broad introduction in the first paragraph. The second paragraph is a historical significance, and then we'll kind of continue on and look what the other paragraphs say. Okay, so continuing on, this is the end of that paragraph right there at the top of the historical reference. There is a posted example of this on Canvas with just the sections we're going to look at. I moved up to the top in modules, so you can kind of use that as a guide. And again, it puts everything in perspective. The next paragraph is looking at how we bake cookies. Again, if you use the author's name, like right here, we have, Amos in 1988. And then if we use the person's name actually in the paragraph, you have Fields as an example. And then parentheses, you'd have 2004. So that's kind of how we do it. Notice that we have page numbers in each one. You can't see them here, but it is page numbered. That will help. It's nice to have page numbers, but you don't have to for that. So this is the next paragraph, putting into, how do we bake cookies? And then, the key one we're going to focus in on this paper is number 2, was where you make a creamy mixture with shortening or butter. And basically, again, from the title, we're going to try to determine which is better to bake cookies, butter or Crisco, which is a form of shortening. So then we continue on and look at the taste and text preferences of the individuals and how that is preferred, and certainly, talks about how people prefer their cookies a certain way. And so slightly crispy and chewy at the same time were preferred, and the flat were preferred over more round. So kind of based on that criteria, which type of baking method would give you the ones that fit that the best. Also then mentions, an example where, this company sold more cookies in terms of national sales based on moving from a shortening based to a butter based recipe. So that kind of gives you a nice background and things like that. And then this is the last paragraph. The experiment is designed to examine, so it talks about what we're actually going to do here, right? So it gives you a little bit of the methods. We will compare 2 basic types of shortenings, put them in quotes because butter and vegetable shortening are different. Crisco will be used as the standard shortening in terms of the cookie recipe. We have our hypothesis, right? Down here, basically, we expect that butter, that's our hypothesis, right? We expect that butter will positively influence the taste and texture of the cookie. So that's what we're looking at the end. So we're talking about what we did, how we did it, and what we expect right here in this area. And you can look at these over here in this side and kind of the notations that I have. This is actually on Canvas. If you go to the farther down in the middle of the paper and lab report thing. A couple other things to note then. While it's hard to see based on this, this is right towards the end of the second page. So this is about 2 pages, right? And that's what we're looking at in terms of a good length for the introduction. Again, if it goes more than 2 pages, it starts to get away from the introductory areas. And if you don't have at least 1 page, then you probably haven't covered all the aspects of the introduction that you should. Remember, we do have an outline for this as well. So what the outline was, I posted before, and make sure you answer that. Also, JLR number 9 should correspond to this very nicely as well. So those are the types of things that you should be looking at when you look at the introduction. So remember, for the purposes of submitting the lab report for grading, we don't do a methods or a reference section, right? But again, we still have references within the body of the paper. You just don't have this in a reference list at the end. So We skip right to results then. Again, just because somebody's going to mess it up, all capitalized, left justified, bold for the section title. Notice it starts with a text section. So we have words. The first part is words, text, and this is going to explain in general what we did. As a rule of thumb, every table or figure that appears in your results needs to be mentioned specifically by name. You can also mention other things that don't appear in the table or table form or figure form. Okay, so but everything, as a good rule of thumb, should be done that way. So we start out here and we talk about, you know, what we did, and say, okay, what's the comparable color to doneness in the level 6 International Cookie Scale Indicator, and then it tells who came up with that. Since we didn't have an author's name here, based on this example of a reference, then we put anonymous. Since we had anonymous A, there's something else we couldn't find the reference for in terms of who wrote it. This one would be anonymous B, and then the date of publication, which would be 2006. Okay, and then we specifically mentioned the table by name. Right, so in this case, it's table 1. Notice once we give the table a number, it becomes a proper name, so it's capitalized, capital T for table. All right, and it basically says that the results in general said that baking time increased as we increased dough size. And then based on that information, we give specific results. Right, so we talk about a range. It went from 9.5 to a little over 12 minutes. Give the different sizes, and then looked at the comparison between these. It also noted, trying to make it come alive for the reader, that the increased cooking time was not linear, right? So it says in neither case was the increased cooking time a linear function. So if you have a trend or data points over time, can you extrapolate from that in terms of that? And so as the cookie sizes got bigger and bigger, the amount of extra cooking time was not needed. So as an example, a 50-gram thing of dough was not twice as long as a 25-gram thing of dough, and so on. It took longer, but it wasn't directly proportional, and so that's what that's kind of saying. And then we start a new paragraph and we talk about cookie spread and how flat they were, and again that data is shown in figure 1, and so now it explains the figure, and it tries to give you the important data points and what happened for that. So it again is trying to make this data come alive for the reader in terms of the text. So now we continue on with the data. Now it's looking at randomly selected people to taste and give texture and rate it on a scale from 1 to 10. It talks about the number of tasters and how we kind of randomize the different things. And ask them to give their preference. Tasters were not given any other information and things like that. And then based on that, right, it shows, here's the results. They're shown in table 2, and that the taste overall was 8.2 for the one and 6.8 for the other. And then further explains table 2 in terms of the other parts, and that's the last paragraph. So note that, as we'll see in a second, every table or figure was mentioned in the text, and in fact some information not even directly related to it was also mentioned. Okay, so now we get into the area where students have the most problems, and so here's a couple things. So this is the second part of the results. We already mentioned these things in the text, so now we're going to go ahead and look at the tables and figures. So there's only two things that you can have in terms of names for this part. You either have a table or a figure. You are expected to have at least one, and you can have more than one, as you see here, and whatever you need for your data. So as an example, though, you don't want to have redundant data for the different points of information. So as an example, since I posted the baking time versus dough size as a table, I wouldn't make it as a figure like this here, or vice versa. And so you have to decide as a writer which is the best way to do it. And when you have less complicated data, sometimes a table makes sense, and there are times when a table would make sense anyway, where the number was more important than the relationship between two variables. So as an example, we measure blood glucose as a test for diabetes. And for those of you writing it, I'm sure you'll find that, or if you look at Lab 19, that a blood glucose of 126 or above milligrams per deciliter is indicative of diabetes. So if you have something like that, that number's probably more important than the relationship between two individuals, and it's the actual number that's probably most important. And certainly there's ways to creatively put that data into a figure, but getting that raw number in your table is probably the most important thing. So you either name it a table or a figure. Notice they're numbered consecutively. The first table is table 1, the first figure is figure 1. If you had a table or figure in your introduction, right, that would be table 1, and the next table would be table 2 as an example. So this table has a title that explains it. So basically it shows the baking time as a function of dough size, right? And then it explains the table. Notice how it's an increase of the function, the dough size for that. I actually added to this for the one that was not abridged and given information about. So it kind of gives you some conclusions and things like that very quickly. You're not going to say why it takes longer, but you can easily say it takes longer. And again, this is a table. To be a table, it has to have rows of things and columns of things, right? So if it's not a table, you have to call it a figure. A figure could include a line graph, a bar chart, a map, a photo, something, a diagram. All those things would be figures. That's a table. Figure does the same thing. It provides information. I added a title to this. That's probably better than what you see here on the one I posted on Canvas. And then an explanation. One of the things that you mentioned about tables and figures is that they should stand on their own. And what stand on their own means is that if you just took this figure, for instance, and laid it on the floor outside the anatomy lab, and students that never had physiology, picked it up when they walked out the door, they'd be able to look at this and know exactly what this figure says without having any reference to the report or anything else. And that's true of each section as well, to some extent, that each section needs to stand on its own. And so that's why, I mentioned before, if you're not feeling like you're being redundant, then you probably haven't done this right. And so, you can generate your figures or tables by hand, or you can generate them on the computer. If you generate them on the computer, the nice thing is if you have to go back and change them, it's pretty easy. If you generate them by hand, it's much more difficult to make a change. I highly recommend, if you use tables, and many of you will, that you do that on the computer. It takes literally 2 minutes to make this table. This figure, though, you might want to think about if you're going to put some sort of figure in, drawing it by hand, or maybe making this outline on the computer and then drawing the rest in by hand and doing it half and half or something. Many students spend hours trying to get a figure like this into their report and end up giving up and doing something else. So let's look at the last figure really quickly and see. It's actually a table, not a figure. So again, here's our last table. It's a table because it's got rows and columns of things. So that's what we look at for a table. And when we look at it, then we can see that it clearly identifies what the table is. It clearly talks about the response on a scale from 1 to 10 in terms of the cookies. And again, it gives some sort of conclusion in the table. And so if you just looked at this without anything else, you should be able to tell what's going on. I don't think most of you would have as many as 3 tables, although it's possible, depending on how you looked at your data and things. But don't present redundant data in a table and figure form, figure out what's the best way and just do that. Since all of these present different information, then they're all viable tables or figures to put in your report. So the last section here is discussion. And the discussion will look at some of the different parts to it. Basically, your discussion is your opportunity to demonstrate to me, the reader, the grader, that you understand what's going on and what the important elements of this paper are, and then can you make connections to physiology and why would we care about it. So what we need to do is we need to discuss, hence the name discussion, and also note left justified, all caps, bold. We need to discuss our results in relationship to what the physiology is. So often a good way to do it is to bring up the results fairly early. So literally in the second or third sentence right here, we bring up the information that we've specifically mentioned a table. All of your tables and figures should be specifically mentioned in the discussion from your results. Students ask how long each section should be. We mentioned 1 to 2 pages for the introduction. The results, it depends on how many results you have. If you're doing 8.4 B or C, like the hyperventilation or the color change through the straw for CO2, those are going to be very short. If you're doing the acid-base buffer water one, then that's going to be a little more complicated because of what you need to think about in terms of that, because it's so many more data points you have to discuss. But I don't think anybody would be over a page or so, and then how many figures and tables you have, which could be on the same page as I presented, or different pages independently, whatever you find the easiest to do that. Note, though, that any result should be in the results section before the discussion, which makes sense. So here it, again, is going to have a liberal use of different authors, right? So it's going to be well referenced. So we'll see multiple references. I'll just underline some of them, right? And so just on this little couple paragraphs, we see we've got 1, 2, 3, 4, 5, 6, about 7 references that we're talking about. So as I said before, we mentioned the table. We explain what happened again. This is where you're going to start to feel redundant. That's a good point. And then why physiologically butter might do what it does differently. Why does butter behave differently? So this goes ahead and gives a little bit of background of what's going to happen in terms of why do we have difference in baking time for the same dough size based on butter and shortening. So it's given a scientific explanation as to why it is. And so it talks about what butter does, and then it basically says Crisco doesn't do this. And also it talks about the quality of butter and things like that, which was not tested in our experiment. And then it talks about and explains the data, right? And in this case, we said, we don't really know why it does this, right? So why does it change the way we do? We're not really sure, okay? So the problem continues to be examined in this section about the different dough sizes and why the cooking times are different, but not a linear function. And so we can see that once we finish talking about the first one, we go on and see later on that we go to figure 1. So again, we're trying to look at every aspect of the results and talk about it in light of the physiology. So you can see that. We can see we still have our page numbers here. So we talk about figure 1. And then once we're done with those couple paragraphs with figure 1, we now bring up table 2. This talks about why it's the most important. The information was posted, right, that people like the taste is given an 8.2 out of 10 versus a 6.8 for Crisco. In addition, it gives the taste preferred 3-to-1. So what it does show is that out of, the 20 tasters, right, 15 or so preferred butter, but 5 still preferred Crisco, right? So it does talk about the different biases and, how taste and texture are dependent upon each other. And certainly, if one was not as good as the other, then it would probably have an influence. And then it talks about what we expected. So here, this is why we said at the beginning, people would prefer butter over Crisco, and it looks at historical references in terms of that, and gave some background information about why that would happen. And then that goes on and continues here in this paragraph, again, talking clearly about, the other part of table 2 that looks at texture and tying the two together, and looking at those things. And then we have the final paragraph. Now, again, going back to length, if you look at the sample cookie report, it's a little less than 3 pages long in terms of the discussion. That's probably too short for most of you, and I would expect at least a 3-page discussion, and that would give you an opportunity to thoroughly explain what we learned, why we did it, what we were doing, what was the physiology behind it, what's the significance behind it, what's the background. Again, it's your opportunity to show me how much you know and understand about this topic. That's part of the reason why we're doing it. So you should be able to go out to the ideas, the literature, go out to the scientific information, pull it together and tell me what's important. So again, if you look at the little comment section, right, it says, to be honest, this section is a bit short. And so, and to be honest, the excellent ones are probably close to 6 pages or more. Just because it's long doesn't mean it's any good. A number of years ago, I got a 10-page discussion that literally looked like somebody just took words and randomly threw them on a paper. So there are those things that we need in terms of the elements. So this is our concluding one, and basically it talks about that the type of shortening determines, right? So whether it's butter or Crisco, what the final baked product is. It specifically mentions what we found, that cookies, bake faster and spread further than the ones with Crisco. We also looked at taste and texture, and both of those are rated higher for butter than Crisco. Again, we basically answered our experimental hypothesis that, yeah, Crisco's not going to be as good as butter, right? Which we talked about before in the last paragraph of the introduction. And then it kind of summarizes everything with this nice little quote for that. So that's kind of a way to look at what you're looking for. Remember, the next section that would normally be the references we're not turning in. Again, this is well referenced, so I'll go ahead and look at a few of the references that we have. So you're still continuing to reference the information and show me, hey, I got this information from somewhere, and I'm going to give that person credit for it, but we're not going to include a reference list because that was done in number 8. So again, as the tools that you have, you use your JLR 9 for the introduction, 10 for the results, and 11 for the discussion to help inform you in terms of the information for these sections. Use the sample lab report, use the common errors, use the basic outline of it, and do the best job you can. This will be competitively graded, and currently it's worth 50 points, which is a fairly significant amount of your grade. So expect a fairly significant effort.